Start recording.
Actually, are you an eye trade? So fun. You're getting better. Shut up.
Okay, I missed the bell, I guess. But anyway, today, some people have already done quiz 6. If you have already done quiz 6, you can start looking at quiz 7. If you are on this list, it probably means you've been away once or twice, and you probably just get caught up on a few things. Arna, yes? There we go. Okay. So, but the bulk of people are sort of like ready for quiz 6, or we'll finish quiz 5 and be ready to do quiz 6 today. So let's take a look at how to choose the naming system. The first choice, and I can print this out for you if you would like when I'm finished, so you don't have to write it down. You can just watch. The big choice you need to make is you need to say, is my compound ionic? Or is it covalent? Okay. Tell your partner, how do you know if a compound is ionic? So let's start with, how do we know if a compound is ionic? It starts with a metal, so you could have a metal and you could have a non-metal. Or you could have a metal plus a polyatomic ion, okay? Is there another alternative to having a metal at the front of an ionic compound? Is there something else we could have there instead of a metal? Is there another positive cation that is not a metal? And where might you look to find it? Yes, I think I heard it. Is it this one? Yes, here we go. Look, way up at the top of your polyatomic ion page, you have positive cations. Now, mercury is still a metal, but ammonium is made of 2 nonmetals. But you do have to recognize that it is a positive ion, so it will be part of an ionic compound. So we would have then either a metal plus a nonmetal, a metal plus a polyatomic ion, or we could have NH4, ammonium plus a nonmetal, or ammonium plus a polyatomic ion. So the 2 key things you are looking for to see if you have an ionic compound: do I have a metal at the start, Do I have ammonium at the start? If I have those things, it is ionic. And if it is ionic, the first thing you need to know is that there are no prefixes. So now let's look at covalent. How do we know that we have a covalent compound? What types of elements do we have? Tell your partner, what types of elements do we have when we have a covalent compound? Does a covalent compound start with a metal or a non-metal? Non-metal. So we will just have a non-metal plus another non-metal. How many non-metals does that make? Does it make 3? Does it make 7? How many? In other words, there's only 2 non-metals. If you have 3 non-metals, it probably means that NH4 ammonium is involved. Like you might have NH4I, non-metal, non-metal, non-metal. But NH4 is part of the ionic compounds because it's a polyatomic ion. So if you have only 2 nonmetals, it is covalent. And if it is covalent, what's the most important thing to know that you do? Prefixes. So those are the main categories. From there, we're going to take a second little look at things, and we're going to say, if we have ionic, the second thing we need to ask ourselves is, does it need a Roman numeral? Or does it need no Roman numeral? How can you tell? Tell your partner, how do you know if you need to use a Roman numeral? Yeah, if the metal is in the red zone. So if the metal is in the red zone, you will use a Roman numeral. If the metal is not in the red zone, then we will have no Roman numeral. Okay? Now I could go on and on about polyatomic ions and things like that, but I'm not going to. Those are your biggest categories. And I think if you've got those big categories down, the rest of it will kind of fall into place. If you're having troubles with the details, I can help you out later with that. Now, let's just remind ourselves of a couple things about covalent and the use of prefixes. Do you remember what we need to do with the ending of the second name? Second name ends in "ide." That's covalent. Do you remember any of the prefixes that behave in a sort of different manner than all the others? Mono. What's different about mono from all the other prefixes? Tell your partner what you remember of that. Mono is used only where? On the second word. And the third thing to remember with those is that you drop Do you remember what letters you drop from the prefixes? O and A. So we drop an O or an A. So instead of mono, we'll just have mon. Instead of penta, we'll just have pent. But we don't drop them all the time. We only drop them in front of who? Oxygen, which could also be oxide. Only in front of those two. And only the O and the A. Don't drop an I. Don't drop things in front of other elements, just oxygen. Okay, I'm going to press print on this. How many people would like a copy of this printout? I'll make a class set. File. Print. 30, 29, 28, 27, 26, 25. Huh? Number of copies, 26. Print. Okay. So I'm going to let you guys take some time to finish off quiz 4 or 5 or 6. There's a few people who have 2s or 3s who have been away for a little bit and need to get caught up on those ones. All right. So if your name is up here, it means that you need to do a little bit of catching up. See if you can get through quiz 6 today, or at least through quiz 5 today, and maybe quiz 6 if you don't. Okay. You can, and in fact, I'm going to go over some quiz 7 stuff right now. Okay, friends, we are going to page 63 because a lot of people have now finished quiz 6. Page 63, 63. Okay, so up till now, up till quiz 6, we have been going from the formula and we have been writing the name. Now we're going to take the name and go backwards to write the formula. So we're going to start with very straightforward ionic formulas, okay? So when you're writing an ionic compound, the very first thing you need to do, remember we're on page 63, and if you're not working on it, you're staying quiet so everyone else can pay attention, right?
Oh, yeah.
Yeah. Okay. First thing you're going to do is you're going to figure out who the two ions are, and you're going to write the formula for each ion. because it is an ion, what do all ions have? They have a charge, so you must include the charge. Now, do you guys remember how much overall charge a compound has? What is the net or overall charge of a compound? Net charge of a compound is always 0. So this means you need to make your total positive equal your total negative, okay? And then we write the formula of the compound using subscripts to tell us the number of atoms. So let's try an example here. We have sodium chloride. Do you guys remember the formula for sodium? And if you don't remember it, go look on your periodic table. Go find the formula for sodium, just sodium. Na. And Na is in column number 1. What is the charge of Na? Plus 1. Even though normally I would just write Na plus, I'm going to write plus 1 here so we can keep track of our numbers more easily. Okay? Chloride, when you see the ending "ide", where will you usually find those? Will you find them on the polyatomic ion table, or will you mostly find them on the periodic table? Yeah, so if you see the ending "ide", it's usually on the periodic table. So we're going to look up chloride. Who is chloride on the periodic table? That is chlorine. So if we go to our data booklet and we look up chlorine, it is in group 17. So its charge is -1. So we have Cl -1. Now remember, we need to make our total positive equal our total negative. Do these two equal at this point? Yes. Okay? So yes, they do. So I don't need to do anything fancy here. I've got 1 sodium and I have 1 chloride. So when we write the formula, we simply write Na. Do we write a little 1 at the bottom? Or do we just leave it? We just leave it. And then we write a Cl. Do we write a 1 at the bottom, or do we just leave it? We just leave it. Now I'm going to give you one more option here. Which option do you like better? Option A or option B? Tell your partner which one you like better, option A or option B. And if you're having trouble thinking of it, think about all the formulas you have seen in the last week. Did they have charges in them or did they not have charges in them? All the formulas from this last week. Charges or no charges? No charges. So we do not want the charges. So just NaCl. Example 2, potassium. What is the symbol for potassium? Potassium is K. Sean and Will, are you guys paying attention back there? They can't hear me. Are you guys paying attention? Ask them if they're paying attention. Are you guys paying attention? Okay. What's the charge of potassium? Potassium is positive. And when it just says positive, how much positive is that? Positive 1. What is the charge of nitride? Remember, "ide" tells us it's on the periodic table most of the time, mostly. Sometimes they won't be. We'll find some of those next day. We go to our periodic table. Nitrogen is here. That's in the column that is -3. Okay? So nitride is -3. So now we ask ourselves, does the total positive equal the total negative? Does +1 equal -3? No. Which one do we not have enough of? We don't have enough positive. So we're going to just add another positive. Okay. How much positive do we have now? 2 positive. Is that enough? No. So what do we need to do? Add 1 more K. So we're going to add 1 more K. There we go. And now our total positive is how much? +3. Our total negative is -3. Now we know that we have the right amount because they are the same positive as negative. How many Ks do we have? We have 3 Ks. How many Ns do we have? 1 N. So our formula then will be K, and we have 3 of them, so we write the number 3. And we have 1 N. Do we write a little 1 at the bottom? No, we just leave it blank. Here are some common mistakes. What is wrong with this one in the box? Yeah, the subscript's up top. It should be down at the bottom. What is wrong with this one? Subscript's in the wrong place. Sometimes people see this charge and they just want to throw it down here, but you can't do that. It tells you the number, not the charge. Okay? What about K plus 3 and 3 minus? There's charges in it, so that's no good either. So you want to make sure you don't do any of those things. Just simple and straightforward. Okay? One more example. One last example for the day. Iron. Let's go look on our data pages for iron. Here is iron. What is the charge of iron? It's in the red zone. So do we know the charge of iron? Not just by looking at the periodic table. So we need another solution. Fortunately, what does this little 3 tell us? That tells us the charge. Don't get fooled. Do you know how many people will write this formula and they'll see iron 3 oxide and they'll be like, yeah, I'm done. Ooh, 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 ooh. Is that correct? No, because this 3 is not the number of atoms, it is the charge. So this would be wrong. If that's the charge, what it means is that we have Fe 3 plus. Okay, so the 3 tells us it's 3 plus. Oxide, you need to go look on your periodic table. What is the charge of oxide? Yes?
Oh, I used to.
You can do that, but I'm not going to teach that to these guys until they've learned this, okay?
Okay.
Yeah. You can use -2. So this is 2 minus. Do we have enough of each charge? Is the total positive equal to the total negative? No. What do we need more of? We need more. We've got 3 positive, 2 negative, so we need more negative. Oh, 2 minus. Let's add another one. What is our total negative charge now? -4. Okay, 2 and 2 makes 4. Are our charges equal now? No. Now we need to add some more positive. How much positive charge do we have now? 3 and 3 makes 6. Are our negative and positive the same now? No, I need more negative. So we're going to put another oxygen. And now, what's the total negative charge? -6. What's good? Oh my gosh, look, positive and negative equal. Hooray! How many irons do we have? 2 Fe's. How many O's do we have? 3 oxygens. So when we write the formula, it's going to be Fe 2 O 3. That's the basis of doing this. Some people will use shortcuts, which is fine if you can do it in your head, if you're good with lowest common multiples. You might look at this question and say, I've got a 3 charge and a 2 charge. The lowest common multiple is 6. So how many 3's do I need to get 6? I need 2 of them. How many 2's do I need to get 6? I need 3 of them. So you can shortcut your way through it a little bit that way. Okay? And that is it for today. I will mark the rest of the quizzes that are in the inbox. So if you need to finish up a quiz, do that. Homework.
But there's no quiz 12.
Prep for quiz 7, 66, 64 to 66, unless you're still working on quiz 6 or quiz 5. Okay?